Hey, I'm here to teach you about limiting and excess reagents. Now, what are those? Well, in chemistry, whenever you have a chemical equation with two or more reactants, one of them is going to be your limiting reagent, meaning that say you have the same amount of both of your, well, in this case it's going to be both because you only have two, but you have the same amount of both of your reactants, but one of these is going to produce less of your products, and that one is going to be your limiting reagents because it's limiting how much, because only so much of it can react in order to create only so many products, and you're going to have some excess, the other one that's not the limiting is called the excess reagent because you obviously have some left over. Now, to figure it out, we're going to use a bit of stoichiometry. Now, first we're going to find out what is our limiting reagent. Now, in order to do this, we obviously are going to need quantities of both, well, in this case, it's going to be both because, again, you only have two, but both of our reactants. And in this problem, 1 mole of the CS2 is combined with 1 mole of oxygen, according to the following equation, which is the limiting reagent. All right. Now we know that we have 1 mole of each of these. Pardon my really horrible handwriting. I am using a mouse to write all of this. I don't have any kind of tablet or anything like that. I'm looking into buying one. Anyways, you have 1 mole of each, and so what we're going to do for both of these is we're going to make a little stoichiometry thing. Now, what stoichiometry is whenever it is used throughout chemistry, and it is used whenever you are converting one quantity of one part of your reaction to another quantity of, it can be another part of your reaction in the same part. But in this case, we're going to use stoichiometry to find the quantity of one of our reactants, and we're going to convert it to moles of one of our ending products. So let's say we have to choose the same one, and honestly, you can choose either one. Let's say I'm going to use CO2 because it has a coefficient of 1, and that's just, I guess, easier to work with. So honestly, I guess it doesn't really matter which one you choose in the end, but I'm just using CO2 for the purpose of using CO2 because it's cool. You know, carbon dioxide. Woo! Okay, anyways. So what we're going to do is we're going to set up 2 sets of train tracks. Now, if you have no idea what I'm talking about, well, this is just the method I use for doing stoichiometry. It is basically putting all of your conversions into kind of a form that is easy for you to handle. I don't know. You'll see. So anyways, what we do to start out is you obviously make this horizontal line here. And we're starting off, I'm going to go with CS2 first. I'm going to label this train track CS2 so I know what which one's which, so I don't start freaking out when my calculations are weird. Alright. So I have 1 mole of this. I'm going to put 1 mole right here. And then I'm going to make a vertical line right there. Now I have 1 mole of CS2. It's always good to label so you know what you're dealing with. Alright, anyways, now I'm going to bring 1 mole down. Well, not 1 mole, but moles of CS2 down. Now, what I'm trying to convert these to is, like I said earlier, our ending of these train tracks, or what we're essentially going to be converting them to, is going to be carbon dioxide. So we're going to look at our coefficients right here, and these are how many moles of whatever it is